Welcome to the NOKIA NRS2 hands-on video series on OSPF multi-area network design. Welcome back if you've been following along from the NRS1 video series. Also, a very warm welcome to our new viewers. I'd however suggest viewing the NRS1 videos first before the NRS2 videos, as it will give you the required foundational knowledge to follow along here. Also, kindly subscribe if you've not done so already. We will be covering the following topics as we proceed with the upcoming videos. We will evaluate the need for a multi-area OSPF network design and its use cases. We will configure autonomous system border routers, ASBRs. We will examine the details, creation and flooding of summary LSAs by the ABRs. We will configure route summarization, which is an important tool for improving the efficiency and scalability of a large network. Virtual links and their use cases will also be covered. We will create export policies to use for the redistribution of routes into OSPF. We will configure different types of STUB areas and discuss the use cases for each type. And lastly, we will examine opaque LSAs, which are used for the flooding of other basic topology information. Before we get on with the lab exercises, let us run through a summary on the OSPF multi-area network design. OSPF is a link state routing protocol that supports hierarchical design to improve scalability. This hierarchy divides an autonomous system into multiple OSPF areas, reducing the complexity and processing demand of the SPF algorithm, especially in a large network. In the early days of OSPF, routers had limited memory and had single processors, making the SPF calculation and frequent topology changes very resource intensive. These limitations often caused performance issues and packet loss as routers struggle to manage a large OSPF database. To address this, breaking the network into smaller areas reduces processing overheads and SPF recalculations. However, multi-area OSPF design also introduces added configuration complexity, troubleshooting challenges, and can lead to suboptimal routing due to packets taking longer paths across areas. Proper design and IP address planning are critical for efficient summarization between areas. In modern times, routers with improved processing power and memory can handle OSPF networks with hundreds of routers, which actually reduces the need for a multi-area network design. In multi-area OSPF, all areas must connect to the backbone area 0, which handles routing information distribution. Now, area border routers connect each areas to the backbone and generate summary LSAs, known as Type 3 LSAs. These are the LSAs that actually share the routing information between areas. And each Type 3 LSA, I should say, represent a single destination within the OSPF link state database. This concludes the summary of the OSPF multi-area network design. See you in the next video where we will start our configuration on OSPF multi-area network. Thank you for watching.